In this video, I'm going to teach you everything you need to know about how to grab onto ledges, jump up from ledges, to grab them, fall, and then to grab and climb up ledges. So stay tuned if you want to learn how to implement this in your 2D platformer in the Godot engine. What's up, everybody, and welcome back to the next episode. Sorry for the delay of the holidays for the last one. This episode's turning out really well. Today we're going to be implementing ledge mechanics, so grabbing ledges, falling from them, jumping up from them, and then adding a climbing animation as well, so you can have that dual functionality of either jumping or climbing, and you can change how to implement that game and how to implement that feature in your game according to your desires. One thing that came to my attention from a comment was in this function right here in the last video from set squish. This is all X. This should be Y. So if you're wondering why your dash was looking a little funky, that's probably why. So now when we do this and we dash, there we go. That's looking much better, much clearer. That's the intended kind of squish effect we're looking for. And the second thing that we are also going to do is we changed our state machine and it was working well, but then as I was working on my other project, I ran into a slight bug with it. And so I'm like, oh, dang it, now I have to change the state machine again. So we are going to change the state machine one more time. It's a very simple change though. What we're gonna do is, for some reason, using the handle state change in the change state was if we hit like run and jump at the same time, sometimes it would like freak out and choose run over jump and you wouldn't get both of them. So we need to do that. And literally what we're going to do is we're going to take this code right here and we're just going to replace the change state code with that. And then I'm just going to add in my standard debug line commented out, but this line is so important to me for debugging certain things. And then we're going to delete that. That's going to throw an error up here. We're going to get rid of the change state because it'll change state now whenever we call a change state in a different state. It's like idle state. We'll just call a change state and it'll manually change right there. And if we do that, that will get rid of any issues where it might like freak out between two states. Oh, and we broke something else. Fantastic. Let's see what that is. Change state. Next state not equal to null. Current state is not equal to next state. Yep, that looks good. Oh, that's why. This needs to be next state. Okay, now we should be in business. There we go. Yep. So now we can, double up on these inputs and we won't get any weird issues where sometimes it just didn't work for some reason. So, yep, game is working as intended now with our dashing, jumping around, having fun, grabbing stuff. And today we're going to learn how to grab those ledges, just like we don't right there, but we'll implement it. So let's go ahead and get into that code. So as always, we're going to add some more raycasts for handling our ledges. So here's our player right here. Nice and spiffy. And so we're going to close down these states, the timers. We're going to come into our raycasts. And then once again, like you all know by now, I like to add a Node2D as kind of like a folder. I'm going to call this ledge grab. And we're going to add 4 more raycasts. So I'm going to call this first one ledge right lower. And then I'm going to copy that, paste. Oh, don't want it like that. Okay, perfect. This is going to be ledge right upper. And then this is going to be ledge left lower. And then ledge left upper. Okay. And so once we get these in position, I'll explain why we're using the raycast and how it works. And then I'm just going to hide these right here just because it gets a little busy. They still totally work. You can even keep them hidden in the editor and run the code, and it'll still totally work. So no need to fret about that. So I'm going to start with ledge left upper, and I've also changed my layout. I've just kind of switched over to this layout. I really like it. The way you can do that is these dots right here send like the scene, so I can send it over here. So now it's right there. I'm going to send it back. So I have my file system here, my inspector with properties, the node, which is the signals, history, which I've literally never used, but we'll keep it there. Import, I've also never really used. And then scene. So the current scene I'm editing in all of its nodes. So, all right. So the ledge left upper. So our target position is going to be 0 here, and then -12. And then its transform is going to be -1, -6. Perfect. And yes, that is hanging outside of our player. So then ledge left lower is going to have a target position of -4. And then we're going to come down to the transform, and it's going to be -1, -1. Something does not look right there. Yep, that's what doesn't look right. Perfect. Okay. And now the right are literally the same as these. They're just going to be mirrored. So this is going to be 12, and that's going to be 0. Transform is going to be 1, -6. Perfect. And then finally, ledge right lower is going to have a target of 0 for the Y, 4 for the X, and then it's going to have a transform of -1, -1. Now, like I said, sorry, that's +1, +1. Yep, that did not save. Sorry, +1, -1. There we go. I'm going to turn on visible collision shapes because in my template project, I have this extended all the way up to the top, and I think that's because the raycasts were acting funny, not being inside of something. So, yep, okay, so that's colliding, perfect, that's colliding. Okay, now it looks like they're working fine. So I'm going to leave it like that, and then if it starts wigging out, we'll change it. So the way ledge detection is going to work is these two raycasts. So let's say we're trying to grab a ledge that's like here to the right. When we do that, let me go see if there's a spot in the world where I can do that. Okay, let's edit the world tiles real quick. Now we're gonna set, no, that's not the one we want. We want that is gonna go there, which means we need to put you there. And wrong one. You. Think. There we go. You there. And you there. So let's run this now. Okay, let's see, that's too short, darn. So we'll just look at it right here for now. So when both of these raycasts are colliding, it means we're not up against a ledge, correct? And this one's set 1 pixel outside of the bounding box, and I just did that so we have to be right up against the ledge. If you want to give your player a little bit more freedom, you can extend these lower raycasts out, like another pixel or 2. But as I jump, and it's going to be pretty fast, you'll see that at some point this top raycast will deactivate, but the bottom one will activate. So did you see that? How like when I do like this little short hop for a split second, how the bottom one activates, but the top one is deactivated? That's how we know that we've hit a ledge. So when this top one isn't colliding, but this bottom one is, that means there is a ledge there that we can grab. And then we can do the code for that. So with that, let us open up our player script. And we're going to come all the way up to the top. Perfect. We have all of our raycasts right here. We're going to add even more raycasts. And I'm going to be lazy and copy them from my project. And there we have it. Those are the raycasts. So it's the same naming convention I generally use. RC for raycast, and then just the name of the raycast. It's the same as the node. And this is just the node path. And with that, we are also going to need one more variable. It's like, I know we need something else, but I can't see it in my code. No, we want it to be... We'll put it right here. So this one's going to be called var ledge direction, and we're going to typecast it to vector 2. For those of you who don't know what typecasting is, give me 1 second and then I will explain it. So typecasting is, in most other programming languages, you have to declare what you're doing. So for C#, if we wanted to do something like this, would be like public, which just means like anything can see this, vector 2, and it would say like vector name equals vector 2, and then your values x, y. So this would be C# code right here. That's how you'd say it. So you have to always declare the type that the variable is. So like if it was a string, this would be a string or an integer. In Godot, you don't have to do that. It can basically infer the type based on the values you give it. But sometimes, and honestly, we probably should typecast it like we typecasted this one. You should practice typecasting, because if you go outside of GD script and use other languages, then you'll be familiar with it. And so this is how you typecast. You're saying ledge direction is a vector 2, and then we're going to assign it to the vector 2.0. And I think that's the only new variable that, oh no, there's one more thing we need to do. So right here, we're going to say use to get the tile map for the tile map layer for ledge snapping. So now we've been using onReady. Now we're going to introduce export. If you don't know what export is, I will explain it in a second. Once again, we're going to typecast this. So export basically means allow the player to select that node. So if I come over here to the world and I click my player, there's now a new variable that I can assign called the collision map. And I'm going to assign the tile layer to that. So what this is going to allow us to do is it's going to allow us to access the tile map data, which we're going to need to get precise snapping onto the corners of our ledges in our game. Alrighty, so now we're going to add a new function to handle our ledge grabbing, and we're going to put it down under handle dash get dash direction. We're going to put it right here, and we're just going to call it function handle ledge grab. So what we're going to say is if RC ledge left lower dot is colliding, so if our lower raycast is colliding, and not RC ledge, and this one we want the upper dot is colliding. So if the lower one, the left lower one is colliding, but the left upper isn't, we're at a ledge. And now we're also going to make sure that the player is facing the right direction, because if we're not facing the right direction, we don't want to grab that ledge. We're going to set our velocity to 0, so velocity equals vector 2 dot 0, and we're going to change state to states dot ledge grab, which we haven't made that state yet, so it's not going to do anything. And this is yelling at us because we have that right there. Lovely. Perfect. So the lower one is colliding, the upper one isn't. We are at a ledge. Make sure we're facing the direction, so -1 is left, and if so, snap onto it. So now this assumes that we just auto snap. If you don't want your player just to auto snap to ledges when they're near them, you can also add right here can add another if for grab, if I can spell, grab key. So we could also be like this, and like key climb. So you have to be hitting the climb key too to grab ledges. A lot of games just kind of have auto snapping, so that's how I have it. And actually, I'm just gonna, for those of you who want to implement that feature, I'm just gonna add this code right here, so you can just like uncomment it and use that. That's probably more effective than adding a comment. Alrighty, so now I'm going to copy this, and we're going to paste it right here, and we are just going to replace the word left with the word right. Switch facing to -1, or to +1, and there we go. And that is our function for handling the ledge grab. Perfect. So now we need to actually create the ledge grab state. So let's come into our state machine, and let's add ourselves a new state. And so we're going to have two states actually. The first one is going to be called, let me pull my reference project so I don't botch this. Ledge grab. And then the second one is going to be called ledge climb. So ledge grab will handle the grabbing, jumping up, and falling down. Ledge climb will exclusively handle the climb animation. And when you look at the video, it may not look super smooth, and don't worry, the theory behind this is very smooth. It's just I'm a terrible pixel artist, and if I added more frames, then the climb up animation would look smoother than it currently does. It's just I do not have the artistic capability to do that, so I just put in the functionality, and then in your own game with your own asset packs, feel free to add more frames so it looks much prettier. Okay, and I'm just going to grab these states. We're going to attach a script here, call it ledge grab state. Save it into our state machine folder, and then we're going to paste this. Call this ledge grab. Just call our pass function here, and then we'll leave that there for now. We'll edit it, and then this is going to be our ledge climb state. Save it to our state machine. Create. Paste that. Call this ledge climb. And there we go. Okay, so that functionality is in there. Next, what we're going to do is we're going to update our sprite, because we've got some new animations that we need. So in our resources, we're going to grab our sprite, and I'm just going to plop it in right there. And it moved it up there, so I'm going to drag it down here, overwrite, and then go to our player. Okay, yeah, so our player shifted, that's what we want to see, because we're going to add 1 but 2, so 2 more vertical frames, because we have 2 animations, correct? We are going to have a ledge grab animation, so let's make that. Go to our sprite, go to our frame. Perfect, since we have 1 and we have 2. And once again, let me reference my reference project so I can see how long this is. So this is a keyframe of like 0.75. Okay, cool. So we're gonna make this 1.5, and we're gonna snap this to 0.05, this to 0.75, and snap that to it. And then we're going to loop it. Okay, so it's just kind of like the legs and the body are swinging a little bit. Once again, I'm a terrible artist, so that's what it looks like. I'm sorry. I'm trying to get better pixel art, but slowly but surely we're getting some improvement, but it's not much. Okay, next we have ledge climbs. Now this one's going to be a little trickier because we got some behind the scenes voodoo magic, and by voodoo magic I just mean we're doing a little bit extra on this. So let's pull up the frames for that. So that's 1, 2, so that's 1, 2, 3, 4. Okay, zoom in a little bit. This animation is going to be 0.4 seconds, so it's quite fast. We'll zoom in even more. So this is going to be at 0.1, 0.2, 0.3, and then we're actually going to copy this key and put it right at the end, like that. Perfect. And now we're going to also keyframe the offset for this sprite. So normally what a lot of people do is their animation is larger. So let me just pull up the sprite sheet so we can take a look at this, and I'll explain what's going on. Holy cow, my A sprite is huge. Okay. Everything is 32 by 32. So I have the climbing up animation right here. And it's all 32 by 32. Generally what people do is they have like a larger 64 by 64, and your player will like be here, 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 and slowly move up. But in order to do that, we have to change the size of everything and the textures, and it's annoying. So I just threw them all right here. And instead of having the player move, we're just gonna move the offset and animate that property of our player. So if we go to our sprite, we click here, and we're going to scroll down to our position, and this first keyframe is going to be 0, 0, so we want it to be right there. When we go over here though, we're actually going to make this 0, negative 13, and we can click here to double check that. See, so that didn't change it. Negative 13, perfect. Then we're going to keyframe right here, and this one is going to be 0, negative 13 as well. So double check that, perfect. And then we go to this next one, and it is also going to be 0, negative 13. So we're going to keyframe that. And then we go to this last one, which is actually going to be back at 0, 0. Let's make sure that's right. Perfect. Okay. Now you can mess with all of these other values as much as you want, like your easing and everything. I'm just gonna leave them as is, just because I don't really want to mess with them, but you can. And then I'm also gonna actually set this to be discrete, just because I like the look of that. Obviously, you can mess with these values too. And if you want to, I'll have another video that goes like super in depth into this, like what these values all mean. But for now, we're just going to be here talking about this. So now if we play the animation, so you can see how the player climbed up and like teleported up, then went back down. And that's because we're at the ledge, we slowly move up, and then here we snap back to 0 because we basically just teleport the player up to the top. And so we don't want the offset to be something else, otherwise the player would be floating above the ground, and we don't want that. Alrighty, now that we have those animations in place, we can go ahead and start working on our ledge grab and our ledge climb states. We're going to declare some constants. So constant ledge release x nudge is going to equal 1, and then same thing, constant ledge release y nudge is going to equal 5. And we're going to declare two variables. Corner grab position equals vector2.0. This one, it's not typecasted, but be in a good habit, you should typecast ledge grab snap position equals vector2.0. So this will be the actual corner of the tile. This will be the relative location we need to snap the player to. Now we have a lot of code in the enter state, so we're actually going to do that last. And we're going to come into the update, and we're going to add 4 functions. So handle, jump, up, and we'll code these in a second. Handle, climb, handle, ledge, release, and then go down. Handle, animation. Okay, and then our handle animations is going to be simple. We're just going to play the ledge grab, and then we're just going to flip the sprite based on the ledge direction. So we're just going to hardcore lock it in based on that direction. Okay, let's do handle ledge release first. So function handle ledge release. And basically what we're going to do is that the player presses the down key or the player's stamina is less than or equal to 0, have them fall. So if player dot key down or player dot climb stamina is less than or equal to 0, what we're going to say is player dot global position plus equals vector2, so we're just going to declare a new vector. Ledge release x nudge times player dot ledge direction times -1, and then we're going to do the new line tab thing. Ledge release y nudge. NUDGE, perfect. Okay, and then we're going to say player dot change state to states dot fall. Nice. Now also with that, what we need to do is we need to do player dot not slim climb stamina minus equals player dot, I forget the name of it, so let's go over to our player state, scroll all the way up to, where's the costs? Grab stamina cost, that's what we want to decrease it by. Perfect. Okay, now we're going to do function handle jump up. Let's jump with a P. And we're going to say if player dot key jump pressed, we're going to say I'm going to copy this in. Player dot global position plus equals vector2 ledge release x nudge times player length direction times -2 ledge release y nudge. Perfect. And then we're going to change the state to states.jump. You can also use -1 here. It's just -2 looked like a little better for me. Just when it's -1, you can still kind of re-grab, but nudging the player 2 pixels off prevents them from grabbing again. So, and that's why that's not seeing that. There we go. And finally, climb up. So handle climb up. We say player, or if player dot key up pressed. So remember that's like our arrow key, how we've defined it, and that is a lowercase r. Player dot change state to states dot ledge climb. Let's change that to climb up. I like that. That just sounds a little better. Alrighty, that is that state done and dusted. So let's go to our state machine and let's add these two states. And we'll change their names real quick to ledge grab. And notice how when we auto pull these in using control, it typecasts it for us, but I'm just gonna get rid of that. Okay, those states are in there. So now if we run this, we should be able to ledge grab. So if we go here and we jump up, it's not working. I know exactly why, because we never call handle ledge grab. So let's copy that, and I put it in my fall state. So I'm just gonna put it right there. And then you can also put it in your jump state. You don't have to, but I like to. Okay, so now, oh yes, errors, we love them. Okay, let's see, key up pressed. Okay. Okay, cool. I missed something in the beginning, because I always do. So we need to go all the way up here to our player key variable definitions. And we're going to add var key up pressed equals false. Let's go down to our get inputs. And we are going to say key up pressed equals input.is action just pressed up. Now let's rerun it. Perfect. Okay, so we're grabbed on. And if we hit up, nothing happens because we get locked into the ledge climb state, which we can't do anything with. So we'll go here. If we hit down, we get an error. Vector 2 constructor. Interesting. I do not get that error my code. Where plus equals vector 2. Okay, let me just copy this code over and see if doing that fixes it. Yep, there we go. Okay, I don't know why. I must have had something wrong, but yeah, see how we're grabbed on, and then whoop, we can just hit down to fall, and then if we hit the jump key, we should get an error, because we always get an error. Yep, change state, that's a capital C. Perfect. This is not working, because I don't think we actually ever set ledge direction anywhere in our code, so I need to go look at that real quick, and we shall do that. Okay, so now jumping. Yeah, because if ledge direction is 0, it's not going to nudge us. So we're not setting ledge direction. I was wondering about that while we were coding it. And I was like, I don't see where we set the ledge direction. And I need to input that code in there. So give me 1 second. My guess is it's going to go in our player. I thought we had an update vectors function somewhere. Handle ledge grab, change state, it's not there. Update raycast. Okay. So I don't know if I've actually talked about this function. I have it in my project, my current project. Well, actually this won't set the ledge direction, so I'm kind of lying, but I'm going to put this function in here anyways. So this function, update raycasts. And this is going to yell at us for a second. will force the raycasts to update. And sorry, we're kind of bouncing around right now. I saw that and I was like, oh, I need to do that because that's a good function to have. And it's also yelling at us because it's like there's no onReady called raycasts, and that's because we're about to add it. So we just control click this right here, drag that in, capitalize that, and then I'll just get rid of that. And now it'll stop yelling at us. Basically what that does is it just goes through everything under here. And it's like it'll get to this and it won't update that because it's not a raycast, because we say if it is a raycast, like if child is raycast 2D, then force the update. So it'll just update all of these constantly. All right, I'm going to pause this real quick and find out where we update that raycast so you don't have to sit here in awkward silence, and then I'll unpause it as soon as I find it. All right, I'm silly. Remember how I said at the very beginning, oh, there's a bunch of code that goes into the interstate that's really important, but we'll do that later. Yeah, that's where we update it. It's all up here. So let's go ahead and actually put all that code in because it's very important. All right, first thing we're going to do is actually get the ledge direction, the variable that we so desperately needed. So get the ledge direction. We're going to say if player.rc ledge left lower.is colliding. And we're using the lower one because that's the one that's actually colliding during a collision. The upper one just detects. We need to see if it's not colliding to detect the ledge. Then we're going to set our ledge direction to vector2.left. And that's why I like using vector2s, because it's really good for the direction. So now we're going to say the same thing, but for the right raycast. And then we're going to set the ledge direction to equal a vector2.right. Cool. Okay, so now here comes the big bulk of the code that's really important for this. Well, let's run this real quick, and I'll show you how that's going to change some things. So now we're snapping, but see how we're grabbing way up here? That's because like the X movement stops. Oh, there's our stamina. We ran out. Stops when this collides, but we want these hands to snap to the ledge right there. So now we need to do some math. We need to get like the position of this corner, and then move the player accordingly. And that's what we're about to code right now. So we're going to say snap the player to the corner of the ledge. And then as a second comment, we're going to say get the tile data to find the top left or top right corner global position. And we're going to set some temporary variables. So if I set a temporary variable that's like very local to a function, I often underscore it like that, and that kind of comes from like a C# because that's usually what I like to program in. Okay, give me 1 sec to type this out, and then I will explain it. Returns a vector to the tile size. Okay, so first thing we're doing. Tile size. This is the size of the tile. We know it's 16 by 16 because it says that on our tile size right here, but we want to get the actual size. And if you're using something else, you know, it'll get the size so you don't have to worry about changing the number. So this is the collision map. This is the export variable that we have way up here. The one that we selected here for our player down here. That's why we did it. That's why we exported it, so that we can access that tile map, get the tile set, which is this tile set, and get the property tile size of that tile set. Now that we have that, we need to do a few more things. So this is going to be tile size correction, and this is going to equal underscore tile size divided by 2 as vector2. So this is going to adjust for the center position of the tile. So when I was testing this, we were always 8 pixels off, and I was like, that's so weird. Why is that happening? And then after like 5 minutes, I was like, oh, duh. This is a 16 by 16. 8 pixels off would mean we're looking at the center, and we need to look at the corner. So we divide the tile in half to get the actual correction for the corner of the tile. Now, this right here, as vector 2, is important. This returns a vector 2 integer. So vector 2i is technically what it is. But there's some functions we want to use, some math functions that aren't in vector 2i but are in vector. This is called typecasting. So we're basically saying, hey, we know that this is a vector 2i, but do some magic to make it actually be a vector 2 value so that we can use vector 2 functions on it. So that's called typecasting. It's very useful. You'll use it a lot in programming. Okay, the next is a temporary variable called collision point. And this is going to tell us where the raycast is colliding. And then lastly, tile chords, which is the coordinate of the colliding tile. The reason I'm commenting this so much is because this is like where a lot of people might get tripped on what's going on, and so I'm just commenting the code so that when you go back through it, you know what's going on. So now we're going to say if player.ledge direction is equal to vector 2.left, so we're colliding with the left first. And we're going to say if player.raycast ledge left lower dot is colliding. A whole bunch of misspellings there, but that's okay. So is the direction left, and are we actually colliding? Now technically, to get into this state, we've already checked this, but it doesn't hurt to be double safe, so we're going to do that. So now we're going to get the collision point. So this is the point where the raycast is actually colliding. So we're going to say player.rc ledge left lower dot get collision point. Okay. And then we're going to say the tile chords is equal to player dot collision map dot local to map. So what this is saying is we're basically saying, hey, here's like a coordinate position, and we want this to convert to the tile map. So this is like tile number like 4 across 3 down. We're converting it to that, not based on like the global position, but where the tile map is in, you know, like if each tile is like 1 unit, we're like 4 units over, 3 units down, or whatever. It's yelling at us because we need one right there. Collision variable to map, collision point, tile chords. Yeah, that's why you don't register that, because it doesn't exist until now. So now that we have that, we can say player dot collision map dot map to local tile chords, and then we're going to actually subtract off that the tile correction, size correction. So this kind of seems redundant. We got a collision point, we went local to map, but now we go map to local. Why is that doing that? Well, like I said, we convert to, let's say we collided with like a ledge that's, you know, 2 tiles over, 1 tile down. This will give us a global position. This will give us the tile coordinates based on the global position. This will give us the coordinate of the tile based on the tile position, but it gives us the top left, or it gives us the center of the tile, and then we subtract 8 and 8 to get the top left. Does that make sense? So, because we're colliding kind of near the top right, but it's not the exact top right corner. So we just use this point to get the tile, to get the tile's top left. Okay, so now we're literally going to do the exact same thing, just switch everything to right. And then you'll see there's one other slight little change we're going to do. So now, yeah, okay, so now, yeah, we just change it to right. So I'm just reading through the code to make sure I have everything right. Is colliding, right lower, pulling tile cords. Okay, that all looks good. Okay, now that we have all that code, now we're going to say ledge grab snap position is equal to vector2, and we're going to say corner grab position dot x plus player dot ledge direction dot x times -1 . So we're snapping 1 over, and then we're going to say corner grab position dot y, and we're going to add 6. Now, I usually don't add random variables. These are called magic numbers when there's just a number and you don't know what it is. And so to be a good programmer, we're actually not going to do that. We're going to say constant ledge grab snap y. Now the reason why we don't use one here is because we're just snapping over 1 based on the ledge direction. So that makes intuitive sense. But this one I don't want to be a floating number. This one I don't want to be a magic number. So we're going to add that there. And then we say player dot global position is equal to ledge grab snap position. Okay, so that's a lot of code to get the tile data, to get the exact tile location to snap precisely. So now if we run that, we get an error, because we always do. Yeah. That's because that's supposed to be a lowercase l. Perfect, boom. And we snap beautifully right there. So we should see that upper raycast collide once we've snapped, because we snapped the player down right there to snap onto it. Perfect. Nice. Snaps well, snaps well. And our player animates their legs. Beautiful. So there's snapping along with jumping and grabbing. I'm going to get rid of the collision shapes now. So now the next thing we have to do is our ledge climb state. And that's actually going to be much easier than the ledge grab state. So let's go here and let's say variable ledge grab final position equals vector2.0. So this is going to be like the final position up on the ledge that we're snapping to. And we just do a quick little if else statement. So we say player dot RC ledge left lower dot is colliding. And actually I'm going to be lazy because it's literally this code right here. And I'm just going to copy it over, but you should be good programmers and type it out to practice. So that just gets the ledge direction. And then we're going to say ledge grab final position is equal to a vector2. And it's going to be magic numbers. We're going to replace them in a second. Times player.ledge direction.x -14. So we're going to say up here, we're going to say constant ledge final position x equals 10, and then constant ledge final position y equals -14. And we'll go place these numbers in. And these are just rough numbers that, but through trial and error, I found look the best for snapping the player up on top. Okay. So this actually doesn't have our handle animation functions. We're going to have some different functions here. The first one is function handle climb up. And in here, this is where we're going to play the animation. Player.animator.play ledge climb. Okay, and then next we're going to say, just kidding, I lied. There is a handle animations. And we're going to say player.sprite.flip h is equal to player.ledge direction.x is less than 0. So we're just saying, is the wall left or right? So if the x direction of the ledge is less than 0, then the wall's to the left, so we'll flip this right. Alrighty, so that's all there. There's one more function we're going to need to add, but I'm going to add these right here real quick. Handle climb up, and then handle animations. Perfect. Now, the next thing we're going to do is, I don't think we've done this yet in this game, in this project, so this is very important. This is part of Godot. Signals, if you do not know what they are crucial to Godot's functionality, and as we get deeper into this game, we'll start using them more. A signal is basically a radio signal. Like, I like to think of it like somebody broadcasts a message from a radio tower, and then we can basically tell certain nodes to kind of tune into the frequency and listen for that signal. So our animator has a signal called animation finished, and it's called, or it's emitted, the signal is emitted every time an animation finishes. So we want to know when our climb animation finishes. So we're going to click here, right click, we're going to click connect. We're going to go all the way down to our ledge climb state, and we're going to connect this function into our ledge climb state. It did not do that properly. Ledge climb state should go there, animation, connect, ledge climb, connect. There we go. There it is. Perfect. And when we get that green button right there, that means that that comes from a signal. Now, very crucial when using this function, you need to check the animation name, because anytime any animation is emitted, this signal, or anytime any animation is finished, this signal will be emitted. And so if you aren't careful, different animations can kind of cross signal, and you'll get some weird functionality. I've run into that error before, and it's not like an error, it's just a bug, and it's really hard to debug. And so I'm just going to warn you that you got to be careful with that. Alrighty, so now if we grab this ledge, we can hit the up key, and we get teleported down below. Sick. That is exactly the functionality we wanted. Why is that happening? I do not know. Let's grab final position. 10. Yeah, times player, ledge direction X. Negative. Oh, duh. Because that's a negative, and that's a negative, so we're getting negative, negative, which is a positive. There we go. Now we're climbing up beautifully. Look at that. Climb up those ledges. Look at, we can slide, barely catch that ledge, climb up it. Or we can slide, jump onto that, and jump up it. Ah, wonderful. Ledge functionality added to our game. Isn't that beautiful? Let's climb up that ledge. So awesome. Absolutely love it. Let's just do this for fun. I'm just going to comment that out, and let's see what weird stuff happens now. It's like if I dash... Oh, actually, weird stuff isn't happening. Well, weird stuff can happen. Just know that weird stuff can happen. This is bad programming right here. Always check your animation names when using this signal. Alrighty. So with that, we have everything we need for ledge grab and climb functionality. It's fantastic. It works awesome. It works swimmingly. We can climb up, we can jump up, and we can let go and fall. So, as always, if this is your first video, please like, subscribe, comment. If this is not your first video and you're not subscribed, please like, subscribe, and comment. And if this is your multipleth video and you've seen many and you're already subscribed, drop a like, drop a comment. We're trying to hit 500 subscribers by the end of 2024. We're so close. We can do it. So I appreciate y'all's help, and I'll see you in the next one.